Okay, Math 8 students, we are starting lesson 7.2, which is solving equations with rational numbers. This is building on 7.1, which was solving equations with variables on both sides. What we're doing is we are continuing to have variables on both sides of our equation that we are solving for, but we're now not just using integers, we are using rational numbers as well, so fractions and decimals in our equations. So what we're going to do is what I've got for you guys is I've got all the steps to solve on the left side of our notes here, and then we're going to work through each of those steps on the right side of our notes. So it looks like a lot, but hopefully it breaks it down a little bit easier for you guys as we go through this. So to solve equations with variables on both sides containing fractions, we need to start by eliminating the fraction from the equation. We're going to use the LCD. The LCD, if you remember, is our lowest common denominator, or least common denominator. And we can remember that this is the same as our least common multiple or lowest common multiple. And remember that multiples are many of that number. Factors are fewer, multiples are many. So we've got the denominator 10, 2, and 5. And we're going to find the lowest common one that they have. So we've got 2, 5, 10. I'm just going to go ahead and list multiples of 2, 2, 4, 6, 8, 10, 12, and so on. Multiples of 5, 5, 10, 15, 20, and so on. And multiples of 10, 10, 20, 30, and I'm going to go ahead and stop there because I can see that my lowest common denominator is going to be 10. So now that I've found my lowest common denominator, I am going to multiply both sides of the equation by my LCD. So I'm going to take 10, right, because that's my LCD, and I'm going to multiply it by this side of the equation, 7/10 n plus 3 over 2 equals, and I'm going to multiply this side of the equation by 10 as well. 10 times the quantity 5 3/5 n plus 2. Okay, so I'm multiplying both sides by the LCD. The next thing I'm going to do is I am going to take it over here. I'm going to distribute, right? And so my distributive property we're going to look at more about our distributive property in 7.3, but our distributive property says that if I have a quantity times, if I have a value times a quantity inside and parentheses, I can distribute this inside my parentheses. So this becomes, instead of A times the quantity B plus C, I can say A times B plus A times C. So this becomes A times B plus A times C, and that they are equal. So I'm going to do that up here with my equation. I'm going to multiply 10 times 7/10 n and 10 times 3/2. Multiply 10 by 3/5 n and 10 by 2. So that's going to look like anytime you multiply a whole number by a fraction, you put that whole number over 1. So I've got 10 over 1 multiplied by 7/10 n plus 10 over 1 multiplied by 3 over 2 equals the other side 10 over 1 times 3/5 n plus 10 over 1 multiplied by 2. Okay? And 2 is a whole number also, right? So I don't actually need this here. I can go ahead and erase this and just write 10 times 2 because they're both whole numbers. Now, the next thing that I can do, because this looks like a big jumble here, is that I want to simplify. And you can always multiply this out and simplify after, but simplify first by cross-canceling. So I'm looking for common factors that are going to allow me to cross-cancel. I know that 10 and 10 have a common factor of 10. So I can cancel this out. 10 divided by 10 is 1. 10 divided by 10 is 1. I'm going to just keep moving through my equation here and canceling these out to simplify. So I've got 10 and 2. And you can go diagonal as well, but there's no common factors here. So I'm going to look at 10 and 2, which have a common factor of 2. 2 divided by 2 is 1. 10 divided by 2 is 5. Keep moving across, looking at my cross canceling for common factors. So I've got 10 and 5 have a common factor of 5. 5 goes into 5 once. 5 goes into 10 twice. And then the last one, I don't need to cross cancel because they are already whole numbers. So now that I've cross canceled, I'm going to just rewrite this so it's simplified. So I've got, this is 1 over 1, right? So 1 times 7 over 1, n, plus 5 over 1 times 3 over 1, so 5 times 3 is 15 over 1, equals 2 over 1 times 3 over 1n, so 2 times 3 is 6 over 1n, plus 10 times 2, which is 20. Okay, these are all over 1, so I can go ahead and say, okay, well, they're all over 1, they're whole numbers, so this is 7n plus 15 equals 6n plus 20. And here I am now to an equation that looks familiar to what we have been doing the past few days. And I'm going to solve for n, right? So the things that I need to do here is I need to get my constants on one side and my variables on the other, right? So constants are ones that do not have a variable attached to their coefficient, and these are my variables, right? So I'm going to go ahead and just start with 6n. I'm going to subtract 6n, right? I'm using inverse operations. This is a positive at 6n, so I'm going to subtract 6n from both sides. That gets rid of it on this side and combines it on the other side. So this leaves me with 6n. 7n minus 6n is 1n, right? Remember, every time you see a variable by itself, it's just 1. So I'm going to write 1n. I haven't done anything here, so I'm going to bring that down, equals 20, because this is gone. I'm going to combine these, my constants, minus 15. I've run a little out of room here, so I'm just going to cross cancel. And so now I have 1n equals 20 minus 15. 20 minus 15 is 5. So 1n equals 5, which means n equals 5. And that is my solution. So the big thing here, remember that we're using, once we get down to this simplified equation, we are using inverse operations to get the variable on one side and the constants on the other, and then solving for the variable. So x, sorry, not x, we're using n here, n equals 5. And that's how you would solve with fractions. I'm going to go ahead and move on to how you would solve equations with variables on both sides that contain decimals. Okay? So this is our little decimal example here. You're going to start by eliminating the decimal from the equation. So just like fractions, where we eliminated the fractions, we are going to eliminate the decimals. We're using base 10 multiples here. I'm just going to, got a little bit of it. All right, so we've got base 10 multiples, which are, 10 times 1, or 10 to the first power, which is 10. 10 to the second power, which is 100. 10 to the third power, which is 1,000. So these are all base 10 multiples, right? So we're going to use those to help eliminate our decimals from our equation. So the first thing we're going to do is multiply both sides by the base 10 value of the smallest place value in the equation. So smallest place value is confusing. That means it is the smallest fraction, not the fewest digits. So it will have the most spaces behind the decimal, right? So we're looking at our example 2 here, where we have, this is tenths, this is 100ths, and this is tenths, right? 5 tenths, 75 hundredths, 2 tenths. So we are multiplying both sides by the base 10 value of the smallest place value. Tenths is smaller than 100. So we are multiplying everything by 100 because that's our smallest place value. So we are going to, when we multiply by 100, remember that we are just moving our decimals. So I'm going to take 100, multiply by 2/10 r plus 75 hundredths, set that equal, and multiply 100 by this to this side of the equation too. So I've got 100 times 5/10 r on this side. Okay. So what I need to do now is I need to distribute, right? So what that means is I'm going to multiply every one of these things by 100, right? Just like I did up in my previous one where I multiplied everything by 10, I'm multiplying 100 by each of these values. So I've got 100 times 2/10 r plus 100 times 75 hundredths equals 100 times 5/10 times r. Okay? And when I am multiplying by a base 10 number, all I need to do is move the number, move the decimal, the same number as there are zeros, and I'm moving to the right. So if I've got 10, that's 1 0, I would move it one place to the right. If I'm multiplying by 100, that's 2 zeros, I'm moving it 2 spots to the right. 1,000 is 3 zeros, so that would be 3 spots to the right. In this equation, I am multiplying by 100, so I am moving each of these decimals 2 spots to the right. So here I'm going to go 1, 2, 1, 2, 1, 2. So this is now going to look like this becomes 2, this becomes 20. So this is 20r plus 75 equals 550, 50r, right? So now I've got an equation that's just got variables on both sides. My rational numbers are gone. I don't have any fractions or decimals, and I can just solve for r. So remember that third step is to combine like terms using inverse operations, get the variables on one side of the equal sign and the constants on the other, and then solve for the variable. So I can combine my variables, right? My constants, I've only got this one here, and I can't move this variable term over to this side because then I have nothing on this side of the equal sign, right? Constants on one side, variables on the other. So I need to move my 20r, and it is positive, so I'm going to subtract. So minus 20r on this side, same thing on the other side, minus 20r. This is gone. Now I have 75 equals 50r minus 20r, which is 30 times r. Then I'm going to go ahead and divide, right? Because this is 30 multiplied by r. Since this is multiplication, the inverse would be division. So divide by 30. And then I'm going to end up with a decimal, right? So I've got 75 divided by 30. Top goes in the box. This goes in 2 times, that's 60. Subtract 15 decimal, add a 0, bring it down. 30 goes into 150 5 times. 5 times 30 is 150, and I have 0. So I've got 2.5, right? So 2.5 equals r, and that would be my solution. 2.5 equals r. So that is the quick version of an example of each solving equations with rational numbers. So you get an example of solving with fractions and an example of solving with decimals. I am going to go ahead, on the back of your notes, there is some additional examples. They are optional to do, but if you still need to see some more examples, I'm going to go ahead and walk through those on a separate video. So if you're done, if you feel okay, you want to try them, you feel good about it, go ahead, stop the video. You don't need to do the ones on the back, or you can do the ones on the back and use the next video as an answer key just to make sure you did them right. Or if you still want some more examples, go ahead, watch the next video of additional 7.2 additional examples, and we'll go through the ones on the back of this notes page. If you're feeling good, go ahead and you are done. If you have questions, bring them in tomorrow. Let's go over them. If you do the additional examples and still have questions, obviously I want you to bring those in too. So make sure you guys are coming in. If you've got questions, coming in with those questions so we can go over them. Okay, so that's it for the basic explanation of solving with rational numbers. Again, more examples if you need them are coming on the next video.